everyone, welcome to my channel. In this video we will learn about the flow and error control mechanisms from the data link layer. So we know some of the characteristics of data link layer are framing, physical addressing, access control, flow control and error control. So here we will learn in detail about the flow control and error control mechanisms. So first of all, what is the flow control? So flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for an acknowledgement. Right? So here there is a fast sender and a slow receiver. Okay, so the sender is sending multiple number of frames and the receiver is not able to it is not able to catch all the frames sent by the sender. So at that time there is a loss of packets, right? So to restrict this, so we are using some flow control mechanisms. Similarly, the another one is the error control mechanism. So it is both error, it is used for both error detection and correction. So if any time any error is detected in an exchange, specified frames are retransmitted. So there is a retransmission if there is any loss of data or if there is any corrupted data. So there is a retransmission of the frames. So this is called automatic repeat request. Right? So whenever a frame is sent from sender to the receiver, suppose if the packet is lost, then the sender will time out and it will again retransmit the same packet. Suppose if the packet successfully received the receiver. Okay, but so for that the receiver will send a acknowledgement to the sender. Okay, so while sending the acknowledgement, if the acknowledgement is lost, so then again the sender will time out and it will retransmit the message. So if there is any corruption data, that means if there is a loss of data or any loss of acknowledgement also, the sender will retransmit the data. If the message is not received to the receiver, then the receiver will send negative acknowledgement. So this type of acknowledgement from the receiver to the sender is called as the automatic repeat request. So we are having two types of acknowledgements here, that is a positive acknowledgement and negative acknowledgement. So we will see some of the flow control and error control mechanisms in this video. So there are two types of protocols, that is the noiseless channels and the noisy channels. So noiseless channels means simplest channel and the stop and wait protocol. So these are the two protocols used in the noiseless channels. So here in this video we are going to learn about the noisy channels, that is the stop and wait ARQ, go back in ARQ and selective repeat ARQ. So ARQ means automatic repeat request. So first of all we will see what is meant by stop and wait ARQ. A stop and wait ARQ. So error correction in stop and wait ARQ is done by keeping a copy of the sent frame and retransmitting of frame when the timer expires. Okay, so here in the stop and wait protocol, the sender is transmitting the frame by keeping a copy of the sent frame, and if the timer expires, that means if there is no response from the receiver side, then it will again retransmit the same message. Okay, so here the name itself denotes that stop and wait. The sender will transmit a message to the receiver and then it will wait for the acknowledgement. So it will wait for an acknowledgement. So if the acknowledgement comes from the receiver side, then the sender will again send the remaining frames to the receiver. Suppose if the acknowledgement is lost or if the packet is lost, then the sender assumes that the data is lost. So again it will retransmit the message by setting a timer. So there are some of the operations of the stop and wait ARQ, that is the normal operation, frame loss, acknowledgement loss and acknowledgement is delayed. So these are the four types of operations in the stop and wait ARQ. So in the normal operation of the stop and wait ARQ, so first of all, the sender will send a frame 0 and waits to receive the acknowledgement 0 from the receiver side. So when the acknowledgement 0 is received, the sender will send the frame 1 and then it will wait to receive the acknowledgement 1 and so on, and the transmission will flow so on. The acknowledgement must be received before the timer expires at the sender side. The sender will keep a timer, it will maintain a timer here. If the acknowledgement is not properly received in a given set of time, then it will assume that the packet is lost and it will again retransmit the data. So next one is lost or damaged frame. A lost or damaged frame is handled in the same way by the receiver. When the receiver receives a damaged frame, it discards it. The receiver remains silent about a lost frame and it keeps its value of the receiver. For example, so if you see the sender and receiver here, the sender will send a frame 0 to the receiver side. The receiver will accept the frame 0 and it will send an acknowledgement to the sender side. So the sender will send the next frame, that is the frame 1 to the receiver. But so during the transmission, the frame is lost here. So the sender will wait for the acknowledgement here. So it timeouts and then it assumes that the frame 1 is lost and it will retransmit the frame 1 to the receiver. The receiver will send the acknowledgement for the sender for the frame 1. So this is how the stop and wait protocol will handle the lost or damaged frame. So here the frame 1 is lost, so it will handle in this manner. The next one is the lost acknowledgement. A lost or damaged acknowledgement is handled in the same way by the sender. How the frame is lost. Okay. So here the waiting sender doesn't know if the frame 1 is successfully transmitted or not. So here the sender will transmit the frame 0 to the receiver and it will receive the acknowledgement here for the frame 0. And then the sender will transmit the frame 1. So the receiver will receive the frame 1, but the acknowledgement here for the frame 1 is lost while transmitting to the sender. Now the sender will time out. So sender will maintain a timer, so it will time out and it will assume that the frame 1 is lost. Okay. So that's why it again retransmit the frame 1 to the receiver. So now the receiver accepts the frame 1 and then it will again retransmit transmit the acknowledgement for the frame 1. Okay, so here the frame 1 is 2 times sent to the receiver, but here acknowledgement is lost. That's why it will time out and the receiver will discard the frame 1 here. Okay, so it will discard the frame 1 here. So again freshly it will send the frame 1 to the receiver. So it will send a acknowledgement back to the sender side. So next one is the delayed acknowledgement. So here the sender is transmitting the frame 0 to the receiver and it will send the acknowledgement here after the sender sends the next frame. So here the sender will send the frame 0 to the receiver. The receiver has to send the acknowledgement for the frame 0, but it is sending the acknowledgement, it is delaying the sending of acknowledgement to the sender. So at that time the sender will assume that the frame 0 is lost and it will again start retransmitting the same frame, that is frame 0 to the receiver. So after transmitting the frame 0 to the receiver, so we are getting the previous acknowledgement of the frame 0. That is the first we have transmitted the frame 0, right? That acknowledgement will be received here for the frame 0. Okay. So that's why this is called as a delayed acknowledgement. So here the frame 0 is successfully sent first time, but the acknowledgement is delayed. It is sent very lately to the sender. So sender will assume that, so it didn't get the acknowledgement, so it will assume that the frame 0 is lost and it will again retransmit the frame 0. So while retransmitting the frame 0, the acknowledgement 0 for the previous frame will be obtained at the sender side. Okay, so that's why it is called as a delayed acknowledgement. The receiver will be waiting for it will be expecting the frame 1 from the sender side, since it has received the frame 0. Okay, so that's why so we are facing a delayed acknowledgement in the stop and wait protocol case. Okay, so next one is the piggybacking. So in the stop and wait protocol, we are using a method called piggybacking. So it is a method to combine a data frame and acknowledgement. The channel utilization is low in the stop and wait. So first of all, why do we use the piggybacking here? So in the stop and wait protocol, a sender will transmit the message. So in the case of stop and wait protocol, the sender will transmit the data to the receiver and the receiver will send an acknowledgement to the sender. So here in the stop and wait protocol, we are using the half duplex communication. So both the sender and receiver are communicating using a single channel, but that single channel is not properly utilized here. So sender will first of all transmit the data to the receiver and then the receiver will send the acknowledgement back. So here the channel is not properly utilized. Okay, so first we are sending data and then acknowledgement. So that why here the communication is only one way, single directional, right? And it resembles the half duplex communication. So in a single channel there is a bidirectional communication, but only one only one side the data is transmitted at a time. So to overcome this problem, we are using the piggybacking method. So this is a method to combine the data frame and acknowledgement. So we are having the data frame and acknowledgement instead of sending the acknowledgement here. So we are adding the acknowledgement to the next sending data frame to the sender. So by using this piggybacking method, so we are having an advantage of the utilization of the channel. Okay, so in the stop and wait protocol, the channel utilization is very low. We can overcome that one using the piggybacking. So to achieve the full duplex transmission is by having two separate channels, with one for forwarding the data transmission and the other for reverse data transfer. But this will waste the bandwidth of the reverse channel that we are facing in the half duplex communication of the stop and wait protocol. So that's why we are having two separate channels, one for forwarding the data transmission and the other for the reverse data transfer. So to use each channel to transmit frame front and back both ways with both channels having same capacity. So here acknowledgement travels along with the next data frame. The advantage of the piggybacking is proper channel utilization will be acquired and cost reduction, and it improves the latency of the data transfer. So these are some of the advantages of the piggybacking method. So in this format, data and acknowledgement. So we are going to transmit the data from sender to the receiver. So first the sender will send a frame 1 to the receiver. So the receiver will send the acknowledgement of the frame 1 along with the frame 2 to the sender. Next the sender will send the frame 3 along with the acknowledgement, previous frame acknowledgement, to the receiver. Next the receiver will send the frame 4 along with the previous acknowledgement. So in this way we are implementing the piggybacking method for the stop and wait protocol.